This video explains exponent laws. Recall scientific notation. That's when you can write really small or really large numbers in a more compact way, using the product of a number between 1 and 10, which was the coefficient, and a power of 10. So why powers of 10? Well, our number system, or the decimal system, has place values based on powers of 10. In other words, 10 to the 1 is 10, 10 squared is 100, and 10 cubed is 1,000, and so on. In order to work with powers of 10s, it's important to understand some laws of exponents. So let's go through some rules for simplifying exponents. An exponent of 0 means think 1. Well, 10 to the 0, the answer is 1. In fact, anything raised to 0 is equal to 1. For negative exponents, think flip. In other words, underneath this 10 to the negative 3, there's an invisible 1, just like there is under any whole number. If we flip this, meaning 1 over 10, that exponent that's on the 10 now becomes positive. Let's try a different example. 1 over 10 to the negative 2. If I want to change that negative exponent into a positive, once again, think flip. I'm going to move the 10 up to the top, and now the exponent becomes a positive. The 1's underneath, but that's an invisible 1, and so I'm just going to not put it there. Okay, multiplying exponents with the same base, meaning a base of 10. The idea is to think about adding exponents, keeping the same base. Let's look at a simple example. 10 to the 2 times 10 to the 3. That really means 10 times 10 times 10 times 10 times 10. In other words, 10 to the power 5. So what you did in essence was you took that 2 and that 3, you added them to get 5. So let's go now to this example. Keep the same base, add the exponents. So negative 5 plus 3 gets us 10 to the negative 2. If we want to turn that into a positive exponent, look at the rule above. Flip 1 over 10 to the positive 2. Now looking at dividing exponents. Same common base of 10. Think, subtract exponents, keep the same base. Let's create a simple example. 10 to the 3 over 10 to the 2. That means 10 times 10 times 10 over 10 times 10. Notice the 10s. The first set of 10s can cancel, the second set of 10s can cancel, and you're left with 10 to the power. Well, there's an invisible 1 understood there. So how did that work? That means that 3 minus that 2 gave you that answer. So let's go back now to the example in the question. 10 to the 6 divided by 10 to the 8. That means 10 to the 6 minus 8, which is 10 to the negative 2. And like the previous question, we can turn it into a positive exponent. Raising an exponent to another power. Think multiply the exponents. So this answer is telling us to, or this idea is telling us to multiply the 2 by the 3. So that's really 10 to the power 6. But how does that work? Well, let's see. 10 squared raised to 3 means, I'm just going to make sure my 3 is nice and clear. That means 10 squared times 10 squared times 10 squared. And once again, if you were to expand this, that means that you have 6 of these powers of 10. Okay, and let's try this one last example where it's a little bit more complex, but we're still going to use our basic rules. Take a look at the numerator. We can do multiplication of bases, so that's 6 plus 3, that's 9, divided by 10 to the negative 2. And now that's division, so that's 10 to the 9 minus 2. And now that's 10 to the 9 plus 2, which gives us 10 to the 11. Hope you understand some of these laws of exponents, and watch for the next video, which is going to talk about exponent laws using scientific notation.